We're live.
Hello, everybody. So, welcome back. I hope you're all enjoying yourselves.
No one's here yet.
No? Okay.
I'll let you know when they...
Late to class.
Okay, one's coming. They're starting to come.
Miss Hannah will explain what would happen to you if you were late for class.
They're coming.
Do you think I should just have the appropriate questions in the chat?
Mm-hmm. They're coming.
And we're back. Welcome back, fourth graders.
Yeah, welcome back, Ahad.
So we've opened up the chat for questions. I just want to remind you that we want to post appropriate questions in the chat. We love the questions. We love getting the questions from you, but they need to be appropriate, and the chat needs to be used appropriately. So enjoy. We're here. We're going to introduce you to the blacksmith.
Yes, this is Jim, our blacksmith. Hi. And Jim is going to do a demonstration of a couple of things and talk about what it was like to be a blacksmith back in days and how important a blacksmith was.
How you doing? I brought along some things to show you. The whole thing about blacksmithing should start with a short history of iron in itself. Iron's been worked for 3,000 years as an ore that was taken out of the ground. It was dug deep out of the earth. It was found on top of the earth. It was found in swamps. Seeing our planet's made up of a very large majority of iron. There were several people, different types of people, not only blacksmiths, that were employed in making iron. And without those people, I wouldn't have a job. Without trees and lumber, you wouldn't have carpenters or a need for them. The whole history of the iron working in this country goes back to the earliest part in Saugus, Massachusetts, around 1620, when we say the Pilgrims landed in Plymouth. North of Boston is Saugus Iron Works. They were the first full-fledged iron plantation in the country, way before we were a country. They made wrought iron, they made cast iron, and they also made finished products in the form of flat bar, round stock, and especially things like nail rod. Nails were probably one of the most valuable things you could find in the early part of the country. They were pretty labor intensive. You take a very large flat piece of iron, kind of like this, and they would run it through a slitting mill, which was a series of discs. And you would heat this and run it through a slitter and cut it up into square bars, at which point the smiths would get it and the nail makers would take it, and they would make various sorts of nails. Without the nails, the only thing you held your buildings together with was wooden pegs, which is primarily what this structure is here and the barn. You'll see a lot of wooden pegs going on. But the iron was a boon to mankind. It made your assembly a lot faster. It held ships, buildings, anything you wanted to put together. But for one of these, there were wars fought over nails. And you would think of a blacksmith shop being a horseshoe shop, where you would take your horse to have his shoes done. And the idea of nailing shoes on came first with the Romans. They were the first guys around 1 AD that started to use nails. Before that, shoes were put on with either rice sacks or a silk sack. The shoe was inside, like putting your shoes inside your socks.
Huh.
And that's how the Moroccans, the Mongols, the Chinese, all the Orientals use that sack theory until the Romans come up with iron. Between the Middle East and the Roman period, they're credited with working iron first to a fine degree. But it doesn't start there. It's what they did with it, and they brought it into fruition with smithing and the like. This shop here is probably the equipment, the machinery we have is of a period of around 1880 to 1920. The blacksmithing, although it was a handcraft, the blacksmiths did become what was later known as machinists. And between the foundries that made the iron and the raw materials, they also started making, monstrous machines like a power hammer. Now, I won't fire this guy up because it takes a bit to get going, but this is about a 1910 Carahard power hammer with a 40-pound head in it. You could take a piece of iron, like you take this piece of a railroad spike. I could draw this out in this hammer in 2 minutes. I could make it about this long. Wow. Otherwise, that would take me about 2 hours. But to back up a little, the blower, which took the place of the bellows, there's a lot of shops you'll see them pump a great bellows. And the great bellows that really goes back to Egyptian and the Romans in various forms. But this blower was part of the era in the mid to late 1800s where the industrial age really became surrounded with iron, with steam locomotives and founding stuff. And the foundries are really what put the blacksmith out of business.
So where did they find the iron? Where would they find iron?
Initially, it was found in what's called an outcropping, where you would have a landslide. And I'd have to go into a real long history of our ancient genealogy or archaeology to talk about where half a mountain fell down and you could see the different layers of soil, rock, and sediment over a millennia, that you would find a darkened layer and at times a rusty layer, and that was iron ore in its purest form. That's where they first got iron from.
There's a few more interesting questions here. So what is outcropping?
Outcropping basically is where a layer of earth is washed away so you can see the different layers, like a layer cake. And the outcropping would be where that seam just becomes visible from the soil and then sediment washing away.
Is it like erosion?
It's eroded, yeah. Yes, it's basically erosion.
And how dangerous was blacksmithing?
You don't do this job without getting burned. When you get burned, then you learn.
Did they have screwdrivers?
Yes, they did. After they invented screws. The funny thing about screws or screwdrivers is, I had mentioned nails earlier, but do you know what's the little turned cuts in a screw called?
Screws?
On a screw, it has the little spiral turn on it.
Mm-hmm.
You know what those are called?
So
Any of the smart kids know?
does anybody know what the spiral wedges?
Yeah, the spiral cuts in a screw are
Spiral
called.
cuts in the screw are called. Does anybody have any idea?
We haven't done simple machine.
I was gonna say, I'm like, wait for that simple
Not
machines
sure.
unit.
Not sure.
Not sure. Hint. It goes in a sewing needle.
They're not gonna know that either.
To speed it up, it's called a thread. But why would you call threads in a screw threads? Well, some smart, I believe it was a Frenchman, however many years ago, I don't know. 1,000, 1,500 years, more than that. But they took a simple nail and they made it round. And they wrapped a piece of sewing thread around it in a spiral pattern. They blackened it with the soot from a candle and then pulled the thread off. So you had the shiny piece of metal where the thread was, and the rest of it was black. Then you take the nail where those marks are, and you slowly rotate it and cut those grooves in the screw with a file. So now instead of having a wedge effect, you have what's called an inclined plane effect as you turn the screw in. So there's another task for you guys on TV land. In school, what's an inclined plane? And what's the difference between a wedge and an inclined plane? You got a lot of homework.
That's it. It's a good lead into the
But
simple
that's where you get
machines and
threads from.
science.
Machines, yeah, we'll be.
That's why they call it threads in a screw.
Did men only do this job?
I know a Swedish girl who's about my height, and how do I put this for school kids? She could swing a 20-pound sledgehammer with one hand, like this, like I swing a tack hammer. And she's pretty.
You have to be strong.
You not only have to be strong, I mean, I'm not Charles Atlas. The trick is using the tools correctly. Because when I have a hammer, I'm actually extending the length of my arm. And if you've ever heard the term foot pounds or foot pounds per square inch or any of that, but foot pounds is a measure of force. And if I take this hammer, it weighs 3 pounds, and I move it 1 foot. If you multiply 3 times 1, you get 3. That's 3 foot-pounds. Now, if I take this hammer up here and swing it about 4 feet, that's 4 feet times 3 pounds. That's 12 foot-pounds. So the difference between swinging the hammer from here to there or from here to there is a great distance. And all I'm doing is letting gravity do the work. That's where the power hammer comes in. The power hammer uses more of a weight factor where the head on that is about 40 pounds. This head bounces in a slide up and down. And you can see it's got some spring to it because of this spring. This will come up, it'll go down real fast, depending on how fast you step on the pedal. The 1 foot or 1.5 foot swing on this hammer, even if you only operate it at 1 foot swing, you're still getting 40 foot-pounds. That's 3 1/3 times more than my little 12 pounds of force I can do over here. You know, and when I incorporate it to take a piece of iron, it's about 3/4 of an inch in diameter, and draw it down to a point, it'll take me a couple heats in the forge on that piece to do it by hand, but I could do this operation in about 30 seconds in that hammer.
So there's a couple of questions. They're
Sure.
concerned about when you mentioned it being dangerous. What happened if you were burned? And was there a remedy for that?
I usually stick my hand in a cold water bucket, say about 4 bad words, and then go back to work.
Perfect.
How long did you have to practice before being a blacksmith?
It's not a length of time. It's we measure it in 2 things: the length of steel that you burn up or mess up, which is a lot, and depending on what skill level you want to attain, it could take a year, it could take 5 years, depends. But still today, as it was back in the guild days of the medieval times, in the 12 and 1500s, that period of time, the blacksmithing was originally, it was called a black art. It was something that was mysterious, how you take a rock and turn it into a hammer or any other kind of tool. But there was a guild system and an apprenticeship. You became an apprentice and studied under a master blacksmith for 2 or 3 years. And you would go out on your own and wander from shop to shop in different towns, and you would be called a journeyman. After about 10 or 15 years of journeyman, depending on what branch of blacksmithing you got into, then you became a master smith. My son last year went to Johnstown, Pennsylvania, to a blacksmith school, the Center for Metal Arts. And that school has journeyman, apprentice, all levels of blacksmithing. He spent 6 weeks out there, 6 days a week, 12 hours a day, running a forge.
How hard was it to make nails and screws?
It's time consuming, using just hand methods. Say, typically a nail is a square rod or a round rod drawn out to a point. When I draw it out to a point, what I'm doing is just extruding the metal as fine as possible. But in an evenly distanced arrangement.
So some of the kids are mentioning it looks like a lightsaber.
It takes a lot of time. There's a lot of waiting. You're waiting for the work to heat up. You're waiting for the piece to come together. But that's, as you're drawing pieces out, you become a point. You wind up with a point. When I start with a piece like this here, and I want to end up with a piece like that, what do I have to go through? Well, first I take the piece, I forge out. Of course, these were done ahead of time. These are done on a special with other tools. What's called a swage and a fuller. And it gives you that form here. You can do this by hammer, but it's quite difficult. Swages and fullers are more of a mold. But starting from here, it's drawn out to this piece, and that's the hot guy. That goes over there. And then it's curled on the end. And after that, we use a punch and a through punch to make the hole. I'm not sure if any of those over there have holes in them.
Oh, yeah.
Was it hard to find iron?
Iron you usually bought from a supplier. In the early days, through the centuries, you would get it right from the foundry. But there's another style hook. This isn't a drilled hole, it's punched. We very rarely use a drill in this shop.
Did the blacksmith shop ever catch on fire?
I hope not. Although there is a lot of fire, involved. It's pretty much contained here. And the fire we use gets a lot hotter than a campfire or a kitchen stove. This fire will go up to 3,000 degrees.
Whew.
Your steel and iron will melt around anywhere from 24 to 2,700 degrees. So you've got more than enough to do everything you need to soften the iron or steel and do whatever you want to with it. Now the whole thing about this arrangement is there's an iron pot here. And that iron pot has a pipe in the side of it that's connected to an air pipe here. Of course, you add more oxygen to a fire, you're going to have greater combustion or burning. I'm sure anybody who's been around a campfire and blown on it knows how that works.
Have you ever made a sword like on Forged and, you know, knives and stuff like that they do?
We'll take a railroad spike and turn it into a knife as a demonstration. It's medium to low carbon steel. It'll make a good knife, a sharp edge. But the trouble with that is low carbon steel, the edge will wear off real quick. The positive side to it is if you use modern steel, like 440 stainless or something like that, it's very hard. It's not hard to forge because it's hot and it is semi-molten. But when you go to try and sharpen it, you have to use something besides a simple file. You know, you have to use a good hard stone or some kind of diamond-edged grinder or something like that to get a really true sharp edge. Basically, with an iron knife, which is what they first came out with, you could sharpen it with a rock or a brick. And I prefer carbon steel myself, rather than the modern amalgams of stainless and all the other exotic steels they have today. But there is a difference. And the funny thing is, when they did make iron, they took it from its raw material. As my material gets all over the floor here. They did take it and they would smelt it and they would pour it in a sand mold out of the furnace. Typical furnace, I don't know if you can see this, but a typical furnace was a very large stone structure. And you'll see them around. You'll see them there's a Beekman furnace, I believe. There's one on the New York State Thruway just south of the Harriman Exchange in Arden. And that was a Civil War period furnace. The product that came out of these furnaces from the first part of smelting iron was iron that was very, very high in carbon. And that was called cast iron. The thing they did was they took that cast iron from the smelting furnace, reheated it, and burned out a majority of carbon in that steel or in that iron. And as they went down and burned the carbon out, you reduce the carbon level in cast iron and you wind up with steel. If you continue to heat that and beat the clump of molten iron at that point, a large block of it, and draw it out, you're beating most of the carbon out of it. You wind up with iron rod or flat, which was called wrought iron. And wrought iron was pretty much what these furnaces turned out. When they got around the middle of the Civil War, this guy Bessemer came out and made something called a Bessemer converter, which was pretty much like a pressure cooker. and he regulated the amount of air and the amount of other elements, mainly carbon, that would be mixed in with the wrought iron, and you would come out with steel.
And that's the guy Carnegie hooked up with?
Yes.
He started the steel industry.
Yes. These here are two standing. This is Arden Furnace. It used to be called Greenwood Ironworks along the New York Thruway in Southfields. Excuse me, that's in Arden. You notice it has kind of an arched opening here. And these arched openings were on all four sides of the furnace structure. This is a shot of the whole furnace plantation. This was down by the old Red Apple Rest in Southfields. And if you notice that this furnace here has a point to it, whereas this one is arched, more of a curve. The difference is the coal they used to fire these was charcoal, was made out of wood. And throughout Harriman Park, there are iron mines.
Oh, okay.
And back in the middle to late 1700s, all the way through 1800, there were no trees anywhere in that part of Orange County. All the wood was turned into charcoal for furnaces and iron making. The coal that was used in the clove furnace with the arch top was anthracite. It was a hard coal. They start with blowing air in the sides of these. If you can imagine, each side of this truncated pyramid shape is they blew air in the one side, they blew air in the other side to regulate it. This is where they got the iron out. And they were just two clay plugs there. And what this is inside, I don't have a diagram of it per se, but inside of this is a big vase-shaped inside that's covered with clay. And that's a giant crucible. You know, it's
A couple of more questions.
it's where the iron was molten. When it was ready to be poured, they would pour this out, run it into a floor of the furnace, and you would get pig iron. That's what they called pig iron. But you can see this is the top of the Southfields furnace here. And this is the bridge that they would come up and dump all the raw materials. You throw in coal for fire, and you would throw in lime as a flux, which grabbed the impurities in the iron ore and hold on to them. So you would wind up with purified iron. And you get rid of that separate.
So, sir, as we're ending, can we just answer just a few more questions?
Sure.
What were some of the household items that a blacksmith would make?
Anything you could see around the fireplace in the Brinkerhoff house would have been made by a smith.
Sorry.
You know, we were a combination manufactory and repair shop. Anything that was made of iron was come out of a shop similar to this. You know,
Were there specific times that colonial black people did blacksmithing? Like, was there a certain, like, their job when they did the job as a blacksmith? Were there specific times of the day?
all the time. We had no hours except to maybe catch a nap. And their pay was, say if you take the colonial period, myself, I spent 44 years as a reenactor. And I think I fought the Revolutionary War 4 times now, from start to finish. Doing blacksmithing, I'd be involved with repairing cannons and wagons, and shoeing horses, and fixing muskets, and repairing bayonets. The swords, you had asked earlier about swords and knives. That was a separate form of master blacksmith. A lot of guys, once they got into journeyman, if they worked with a knife maker or a sword maker, that would become their life's work. And that's where they started to branch off. You've heard of the terms goldsmith, tinsmith, blacksmith. Very few people have heard of whitesmith. And a whitesmith is a guy, you rewind to medieval times where men wore armor. All right. Initially, the blacksmith would take sheet iron and they would form it in the forge and make the separate pieces. And then a whitesmith, which was nothing more than a filer, would simply take possibly softened brick, clay brick, as a polish agent and a file. And file the scale, which is the gray coloration and the oxidation on the steel, and they would just file it till it shined. The brick dust was used to further polish the iron or the armor. And you see, you could take any piece of iron, run the scale off it, and it becomes nice and shiny. And that's what these guys did all day. They might as well have been called filers.
So we have one last question.
Sure.
Do you enjoy being a blacksmith?
I guess, I've been doing it. I've been doing this as long as I've been doing Revolutionary War interpretation. And
Do you find that it's hard work?
It is hard. Yeah, that's why after a while your wrists wear out. I don't know if it's the work or the age, but it doesn't matter. It's fun.
Well, on behalf of the fourth graders at Gayhead, we really appreciate meeting you today.
There
Thank
are
you
schools
so
and
much.
clubs you can go to today that I can give you information for.
That would be fabulous.
That'd be
There's a
good.
national organization called Abana, and there's our local Northeast Blacksmiths chapter that's up in SUNY campus at Shokan Field. That's up in Beaver Kill, New York. It's about maybe an hour's ride from here. And twice annual, they have a meet. And there's upwards of 100 blacksmiths that show up there. This is not a dying craft.
Fantastic. Well, thank you so much. That's what we're hearing now. Thank you so much.
You're
Thank
welcome.
you.
Bye.
Thank you.
Bye, guys.
Appreciate it.
And girls.
Thank you.
Are we off?
We're off.